Welcome to 5.1. An exponential function is any function of the form f of x equals b to the x, where x is any real number and b is greater than 0. And b can't be 1, because 1 to some power is just 1. Notice the difference between this and what we're used to. What we usually have is something like x squared, where the variable is in the base, but now exponential functions, we would have something like 2 to the x, where the variable is actually in the exponent. Characteristics of the exponential function. B is always greater than 0. If there's a negative, it's outside of the b. If I said negative 3 to the x power, the base is 3. If I had negative 3 squared, that's equal negative 3 times 3, as opposed to if I have negative 3 squared, which is negative 3 times negative 3. The exponent only acts on what it's next to. That squared is just next to the 3. It is not anywhere near that negative sign. We would only square the 3. If we put parentheses around it, now it's next to the parentheses. We square whatever's inside of the parentheses. And this is equal to positive 9. Domain of f of x equals b to the x is all real numbers from negative infinity to positive infinity. And the range just goes from 0 to infinity. Because if I have 2 to the x as an example, well, could I ever make that equal 0? No, there's no 2 to the 0 is equal to 1. And when we start making it negative, it goes into the denominator as a positive exponent. The base is greater than 0. There's nothing here that would make an exponential function negative or 0. The domain is any value of x, but the range is just from 0 to infinity. We'll do a graph of it so you can see what it looks like. Remember, we have b to the x. Now, whatever base I have to the x power, when x equals 0, I have b to the 0. Anything to the 0 power equals 1 as long as b does not equal 0. Anytime you're graphing an exponential function and it's just b to the x, we're always going to go through this point, 0, 1. When x is 0, y is 1, always. I can do transformations on it, so I'm not saying it can't change, but no matter what the base is, if it's just to the x power, it always is going to intersect at the y-axis at 1. And then what this means is that as x gets bigger and bigger, y gets bigger and bigger. As x goes to negative infinity, it gets smaller and smaller. Why is that? Well, let's say I have 2 to the 0 power. Well, that's equal to 1. How about 2 to the negative 1 power? That's the same as 1/2. 2 to the minus 3 power is the same as 1 over 2 to the 3rd, which is 1/8. Notice what's happening as I make my x more and more negative, the fraction gets smaller. 1/2 is bigger than 1/4. 1/4 is bigger than 1/8, and so on. The bigger the denominator, the smaller the value of the fraction itself. Also, there is a horizontal asymptote at y equals 0. There's no way I can make this equal 0. I just get closer and closer to that line. And the function is 1 to 1. A function passes the vertical line test, and 1 to 1 means it also passes the horizontal line test. If my b value is between 0 and 1, remember it's not ever negative, then it's going to flip. And let me show you why that happens. Let's say I have b is 1/2, because b is between 0 and 1, squared. This is 1/4. But I could also say this is the same as 2 to the minus 1 squared, which gives me 2 to the minus 2. I want to make sure that you really understand your exponent rules, because we're going to be working with exponents a lot. I'm going to write some of the rules out here. If I have a base to a power times the same base to a different power, I add exponents. If I have a base to a power, I multiply exponents. If I have a base to a power divided by a base to a power, then this becomes that base, and I subtract the powers. If I have b to a negative power, it's 1 over b to the positive power. And if I have 1 over b to the negative power, it becomes b to the positive power in the numerator. If I have a b that's between 0 and 1, it actually acts as if it has a negative exponent. When it has a negative exponent, that negative is affecting the x. This would be a horizontal reflection over the y-axis. Now we want to evaluate these exponential functions. There's no way to do these without a calculator. 3 divided by 7, and then I would hit the equal sign. This is equal to 0.4288571. Now, it just depends on your calculator. Some calculators have this symbol. That means exponent. Some people will have something like x to the y. That also means exponent. A to the b. Not every calculator looks the same, but it's going to have one of those things. Once we get the 3 divided by 7, then you would use whatever it is your particular calculator uses for exponents, and you would take that to the 0.6 power, and the answer you would get would be 0.601470. Now, for this one, first, 5 divided by 8 equals x1, and then we would take x1 to whatever that power is. Now we're going to take the x2 and multiply it by 9, which gives me 10.734640. E squared gives me 7.389056. This is the same as 1,000 times e to the 0.013. Evaluate this first and then multiply by 1,000. And the answer you'll get is 1,013.084867.